This is an Algebra 1 lesson on expanding polynomials, multiplying polynomial times polynomial. First off, let's review our exponent rules to make sure we remember them. Recall that the product of powers, when you multiply a number with an exponent times a number with the same base with an exponent, the shortcut is to add the exponents. So this would be equivalent of saying a times a times a times a. It means write a 4 times. So you've written it 4 times. Then you're going to multiply. Then you write a 3 times, and you're going to multiply. So you've written it 4 times. Then you wrote it 3 times. Oh my goodness, I wrote it 7 times. So the shortcut, when you multiply powers with the same base, you add the exponents. Now remember, when you get these things mixed up, go back to the basic, what it is, not the shortcut, like I've just done. If you get a brain freeze, write down a times a times a times a, then a times a, and then you say, oh, that's a to the 7th. Once you do that enough times, you'll get sick of it and you'll remember the shortcut. But don't just guess on what the shortcut is. If you get befuzzled, figure it out the long way. Do the long cut. Okay, power of a power. A power raised to a power, multiply the exponents. Again, everything's all the same base. So, what this means is that you are supposed to write in the parentheses 3 times. So you're supposed to write a to the 5th times a to the 5th times a to the 5th. Then each one of those a to the 5ths, you're supposed to write a 5 times. And you say, I wrote it 5 times, I wrote it 5 more times, I wrote it 4 more times. Oh my goodness, I've written it 15 times, which is the same thing as 5 times 3. Power of product. Each one gets the exponent. Don't call this distributive because it's not. The basis for this one, again, if you get brain freeze and you can't remember it, is you're supposed to write everything in the parentheses 4 times. So you're supposed to write AB times AB times AB times AB. And then you look at it and you say, oh my goodness, I see that I've written A 4 times to multiply. And I've written B 4 times to multiply. Oh my goodness, I can write it this way, A to the 4th, B to the 4th. Shortcut is each one gets the exponent. If you have trouble with the shortcut, go back to the original. Don't just guess. Okay, let's start out with some of the basis for these things. First off, you'll recall, I hope, from earlier in Algebra 1, that what you need to do is, let's start with just a plain old distributive problem, because these that we're going to do now are going to be like distributive property on steroids or something. It's going to be like distributing all over the place. So let's just start back with what we know about distributing. If you say 5 times x plus 2, a reminder, everything in the parentheses needs to be multiplied by 5. 5 times x plus 5 times 2. 5x plus 10. Now you knew that. And a reminder here, what if you have 3n times n squared plus 1? What's that going to be? 3n times n squared is 3n cubed. 3n times 1 is plus 3n. Okay, you should be remembering this stuff. Also remember that although we don't do it very much, you can also do it backwards. For example, you could have x plus 2 times 5, and that'll work just fine. You can say, 5 times x, 5x, 5 times 2, 10. This one, the same thing. You could have n squared plus 1 times 3n. Wouldn't matter. 3n times n squared is n cubed. 3n times 1 is 3n. Why does it not matter? The multiplication is commutative. So whenever everything is all multiplication, it doesn't matter which order they're in. Okay, up to the next level. Let's try this. What if we have x plus 1 times x plus 3? Okay, now that's looking a little more strange there. And we're going to have to do some heavy-duty distributing here. Let's think about how we would do that. Okay, well, everything in the first group has got to be multiplied by everything in the second group to get this 10 to 2. Everything in the first group has to be multiplied by everything in the second group. Okay, let's see what that would look like. I'm going to use one of these backwards distributive properties. You'll see why later maybe. Okay, so I'm going to do x plus 3 and just do that whole group times x and that whole group times 1. So that'll be, you see that? The whole group times x, the whole group times 1. You don't really have to write that 1, but sometimes it's easier to see what you're doing if you do. Okay, so what did I do? I just thought of this whole group right here, x plus 3, and I multiplied it times x, and I multiplied it times 1, and they're positive, x plus 1. So times x times the plus 1. There we go. That's what I did. Okay, now from here, it's just what we're already used to. Okay, so from here, it's just going to be x times x is x squared, plus x times positive 3 is 3x, plus 1x, don't have to write the 1, plus 1 times 3, which is 3. That's what it looks like when it's fully expanded. Now we need to combine our like terms. A reminder, there are like terms when the variable portion is exactly the same. So here, this is an x, but it's squared. The exponents have to be the same as the variable. So it's got to be the same letter, and it's got to be the same exponent, exactly. So this is x squared, which is different from x without a squared, but x and x are the same. So these are like terms. They are like terms, and we can add them. What will we get from that? We'll say x squared, there's no other x squared, so it just stays, and we just copy it. Then 3x plus 1x is 4x. 3, there are no plain constant terms, so it's just 3, we copy it. So that is the final version of this. Okay? Let's do another one. 2n plus 1 times n plus 3. Again, I'm going to do it as this whole group, n plus 3 times 2n and times 1. What will that look like when I'm done? It'll be 2n times n plus 3 plus 1 times n plus 3. Multiplying that out, combine my like terms, and that's the final version. Okay. Next up, let's practice. First off, let's see a really messy one. I mean, like really exceptionally messy. You can do this with 2 and 3. For example, you can say, I'll do a simple one first. So x plus 1 times 3x plus x squared minus 2. I'll do all of that. X times each one of those. You can go either direction. So x times 3x would be 3x squared. X times x squared would be x cubed, and x times negative 2 is negative 2x. Then I do all the ones. 1 times 3x, 1 times x squared, 1 times negative 2. When I do this, I'll have like terms. Okay, I've got an x squared and a cubed and an x. So which one to, okay, I'll do the highest power one first. So I'll do x cubed. Remember, we place them in order, descending degree of the monomial whenever possible. It's not always possible. X cubed, I've done that one, so I'm going to mark it out. 3x squared plus x squared. That's 1x squared, so that's plus 4x squared. I'm marking them out because I'm going to miss them if I don't. Negative 2x plus 3x is plus 1x, and I don't need to write the 1, and minus 2. Okay. So we'll do this. Everyone in one group has to be multiplied by everyone in the other group. I'm going to show you a messy one. This one's really messy. This one's a lot of fun. The ones that we've done have been done horizontally. We do it across, write it out, pick them up. So what's the steps here? Again, we'll multiply one group by each item in the other, and then resolve it out. Combine our like terms. Here's a messy one, and this is all horizontal. We're going to try it vertically. I'm going to do n cubed plus 5n squared minus 7n plus 2 times n plus 3. And I'm going to write it out vertically. Just like third grade math. N cubed plus 5n squared minus 7n plus 2. Okay? And then just like in third grade, when you learn to multiply, I'm going to put them down on top of each other like this. Okay. Now you may recall, I'll put this to the side for a moment, when you were multiplying, well, you recall how to multiply. So let's do it one at a time. Let me show you what we're going to do. The columns now, remember I'm going to go back to it. The columns for multiplying. Say if you had 137 times 21 and you multiply it out, did I do that right? Okay, and then add it. Hopefully I did that right. When you're doing it regular like this, each column, as you go down the page, this is always the ones, this is always the tens, this is always the hundreds. So wherever you are along in your calculation, wherever the number is, it stays in its proper place. The ones, the tens, the hundreds, the thousands, and that sort of stuff. So in regular multiplication with just numbers, you have place value, and it's by tens and hundreds and ones. Here, for expanding our polynomials, multiplying our polynomials, you have place value, but what it is actually is the power of the variable will make our columns. So this is n to the first power, n squared, n to the third. So everything in here needs to have an n squared, an n to the third, and n to the first. And of course here this one is n to the 0 power, which is 1. 2 times 1 is 2. So we don't really need to write the n to the 0. Let's see how that works out here. Okay. Here it is all well, I'll do it. I'll talk it out. 3 times 2 is positive 3 times positive 2 is positive 6. Positive 3 times negative 7n is negative 21n. Positive 3 times positive 5n squared is positive 15n squared. Positive 3 times positive 3n cubed is positive 3n cubed. Okay, I did the first one. That's the same thing we were just doing, the whole group times the first one, but now they're lined up by place value, where place value is the exponent of the variable. Let's do the second one. N times 2 is 2n. Positive n times positive 2 is positive 2n. Now this is an n, so it's going in the n to the first power column. It does not go in the column for n to the 0 power. Nothing goes there. Just like when you do multiplication in 3rd grade or 4th grade, whenever you had it by 2, you skip up space here, either put a 0 there, which is fine, or just leave it blank, either way. So let's do the next one. N times negative 7n is going to be negative 7n squared. It goes in the n squared column. Then n, positive n, times positive 5n squared is positive 5n cubed. N times positive n times positive n cubed is positive n to the 4th. And notice now that we have to have an n to the 4th column. Okay. So, now I'm all done. So I'll come here and add it all up by my columns, just like I did in 3rd or 4th grade math. Positive 6, negative 21 plus 2 is negative 19n. 15 minus 7 is positive 8n squared. 3 plus 5 is positive 8n cubed, and then we have the positive n 4th. It's at the front, so we need to write the positive. We get exactly the same result as we got when we did doing it horizontally, but we're doing it vertically. The reason we're doing it that way is sometimes with the long ones, it's handy to see the ones who have the same value, the same variable, the like terms, okay? The like terms are on top of each other and easy to spot. Also, if you miss a power, you kind of notice it because it's in the wrong column and it doesn't look right, okay? So, that's what this looks like. You do not have to do that. You can do it horizontally, you can do it vertically. It doesn't matter. It'll be fine either way. But that's another tool for you. Me personally, if it's a big long thing, I'll work it out this way because I hate trying to I always think I'm going to miss one of these like terms. And it's just right on top of it. And if it's a little short one, I won't do it this way. I'll do it horizontally. Some kids like to always do it one way or always do it the other way. And some like to do some of each. Whatever you choose, whatever you're comfortable with is fine for you. You don't need to do it another way. Oh, by the way, here's a really big, messy one that you might like to see. 3 times 3. This is so far beyond anything that's Algebra 1, you just don't need to worry about it. If you can do this, try working that one. Don't look at this. Try working that one. See if you can get it. See how it comes out for you. Okay. Now, this is more Algebra 1 level. So go ahead and practice these. Do every last one of them in your cipher. You got to get good at this. If you don't get good at it now, you will be in a mess for the rest of forever every time you take anything that has math in it. So get it right, practice it, actually do it. Pause the machine, and I'll put the answers up. Here's the answers. Make sure you're doing it right. Okay, next up, let's talk about something that you're not going to do. You're just starting doing this, and this is really common right here. We're going to do a whole lot of a binomial times a binomial. Something like this, binomial times a binomial, is going to come up a whole lot. And as you're being new at it, somebody's going to say a word to you, and the word's going to be FOIL. And when they say FOIL to you, what I want you to do is refuse to listen. Put your hands over your ears. Put your fingers in your ears. Go blah, 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 so you can't hear what they're saying. Do not listen to them. FOIL is a shortcut, and I will teach you the shortcut when it's time to learn the shortcut. Please don't learn it now. I've been teaching algebra for close on to 20 years. 1 year I taught FOIL first off, and another year kind of too early, and it just confuses people. What happens is they can do the 2 to 2, binomial and binomial, really easily with FOIL. It's a good shortcut. They can do it really easily, but all the other more complicated ones, they can't do. They get confused because they keep trying to use this shortcut, and the shortcut does not apply. The shortcut only applies binomial times binomial. It works really nicely for binomial times binomial, and I will teach it to you soon, but not now. I want you to learn to do it well and firmly, and don't let anybody talk to you about FOIL. Please. Okay, enough of that. Next up, a special case. What if I have, let's see, if I say, 4 squared. What am I supposed to do if I see 4 squared? Okay, that's just lazy school of mathematics. I know that what I'm supposed to do is say 4 times 4 and multiply it and get 16, right? Okay, so what if I have x plus 4 squared? What am I supposed to do with that? Pray tell. Okay, what I'm supposed to do is write the entire base 2 times and multiply. So that would be x plus 4 times x plus 4. Then I go ahead and multiply it out like we've just been talking out. I'll get x squared plus 4x plus 4x plus 16. And then I'll get x squared plus 8x plus 16. Okay, that's what I'm supposed to do. I'm supposed to take the whole base and write it 1 time, 2 times. That's what I'm supposed to do. And multiply by multiple. Everything in one group times everything in the other group. Okay, here is what I am not supposed to do. As in, not supposed to do. X plus 4 quantity squared equals x squared plus 4 squared. No. 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 It does not. The exponent shortcuts only apply to multiplication. Is this multiplication? This is not multiplication. You know how you can tell it's not multiplication? Because there is an add. There is a plus. It is not multiply. Okay? What would be multiply would look like this. It would be 4x squared. Then it is correct. It is 4 squared times x squared. This is multiply. Therefore, you can use it. Okay? This is not multiply. Okay, let's practice a few of these, please. Pause it and do all of these. Actually do them all. Actually put them in your cipher. Yes, I mean it. You need the practice. We need to get it really well founded in you. Okay, once you've got to pause it, here's the answers. Make sure you're getting what you need. And let's look at the next circumstance. This is another special circumstance where we're multiplying polynomials. So this one would be, what if you have x plus 7 times x minus 7? Let's look what happens when we do that. Okay, I'll do x times x, which is x squared, x times negative 7, which is negative 7x, 7 times x, which is 7x, 7 times negative 7, which is negative 49. Look at these middle terms. They are like terms. They have exactly the same variable with the same power. But negative 7x plus 7x is 0. So what is it simplified to? X squared minus 49. This is a pattern. I want you to get practice with this pattern. Do them. Do them. Yes, I know you can do them. Yes, I want to see that you can do them. Write them down in your cipher, please, please, please. Okay, do each one of them. Pause the machine until you get it. And here are the answers. Make sure you're doing them right. Okay, one more thing. One more thing. Function notation. Y'all remember function notation? Okay, I hear you groaning. Yeah, I know you don't like it. But we do algebra for many, many different disciplines, and we need to learn it the way that each discipline wants it to be done. Okay, let's remind ourselves what function notation means. This is not f times x. This means the value of the function at the point x, at the value x. The value of the function at x is x plus 4. That's the same thing as y in our more commonly used equations. This is a g. It's not an x, but it's still a function. And it is not g times x. It is the value of the function g at x is 2x minus 3. So this is the same thing as a different function, and it's y in this function and y in this function, and they're not the same function. Okay, so then just remember it's terminology that's giving you the problem here, not substance. So let's make sure we can work through it. Our first assignment here is to do f of x times g of x. Okay, f of x times g. Well, what's f of x? Oh, well, f of x is x plus 4. And then I'm going to multiply it by g of x. Wait, I got to multiply all of x plus 4 times g of x. That means I need parentheses. Otherwise, it won't look like I'm multiplying the whole thing. So you got to put parentheses. It's a group. It's a stealth group, and you got to put the parentheses around it now. Okay, times g of x. Well, what's g of x? 2x minus 3. You see, if I don't put the parentheses, it'll look like I just multiplied 2x times the whole thing. No! I got to multiply all of the group. 2x minus 3 times all of the group, x plus 4. So you got to add parentheses. You got to put them in there. Okay. 2, f of x quantity squared. All of f of x squared. That means that f of x is the base, and I got to write it twice and multiply it. Well, f of x is x plus 4. And again, the parentheses, because it's got to be the whole thing. I need to write it twice and then multiply it out, like we've just been doing. Number 3, now it's g of x quantity squared. Well, g of x is still 2x minus 3. I still need parentheses to show that I'm doing the whole group times the whole group, and another 2x minus 3. That's what it'll look like. Then you expand it out, go ahead and multiply it the way we've just been practicing. And here endeth the lesson.